Okay, we'll start. This presentation will be available on replay after it's been edited by the comms team. Good afternoon, everyone. Thanks for joining on this Easter holidays, well, just before the Easter holiday. I'm Evan. I'm member of the Gaia-X CTO team and of the Gaia-X lab. And today we will be talking about Gaia-X trusted execution. So to summarize, we will talk about Sigstore, Cosine, Kyverno, and a bit about SGX. Why are we talking about trusted execution, signature, cryptographic material? We are working on trust at Gaia-X. We are trying to make the interactions between companies and people trustful. And how can we be trustful if we don't have trust in the deliverables the association provides and on their execution? Well, that's the question we are answering there. We want also to help people to run the software without having to rely on contractual negotiation, meaning that at some point we would like multiple instances to run just popping in the wild. This is done in several steps. Some of them are already done and some of them are in progress. We are talking about signing the Docker images we provide, enforcing these Docker images signature on deployment, and running the software in trusted enclaves, trusted environment, and in the end, issuing attestation for the software that is running in trusted environment. We'll start by Sigstore. So basically, Sigstore is just a decentralized community managed signature store, meaning that we use it to store all signatures. We sign Docker images, and the signature is available in Sigstore, and you have access through its transparency log to all the detail you need to trust that the component you will be using is legitimate. So we store a signature of images, we can store binaries, well, signature of binaries. And the good point is that it's free of charge and fully open source, which is pretty cool. So that's a small picture issued from Sigstore's website. You can see that that's the developers, the maintainers, the monitors that sign and publishes the artifacts that are then displayed in Sigstore. To use Sigstore, we use well, part of the project that is called Cosine. That's a CLI tool that allows to sign the Docker images. It perfectly manages the key pair automatically without hassle, without having to manage the key, rotate them, store them somewhere secure. So that's a perfect tool for us. I do have an example of its integration in GitLab CI pipeline. And as you can see, it's easy as cosine sign my Docker image, and that's it. It will generate the signature, store it next to the Docker image and in the transparency log. So that's pretty cool. Doing so, Cosine will provide a T-log entry, a transparency log entry. And using this ID, I can just ask the Sigstore to give me all the info I need regarding the signature. In this case, we built the compliance engine. It was done on the development branch, and we can see that the signature was issued 16 days ago. And we did it because you can see that it was done on our GitLab pipelines, so can be trusted. Now that we have Docker containers that are signed, and we can be sure that we are the only one providing these signed Docker images, we need to help and to be sure that the deployed version of the compliance engine, the registry, the notary are in fact the one we signed. To do this, we proposed to use Kyverno. So Kyverno is also an open source software, free of charge, provided by the amazing Kubernetes community. And it runs in the cluster, and is used to enforce policies. You can enforce the fact that some tags need to be applied. You can force that container image cannot run as root, for example. And you can also require a container to Docker image to be signed. Okay, lost the image there, no problem. Basically, I had an example of a policy, but you can find them on our GitLab repositories. They are available on the compliance engine, the registry, and the notary. And they just enforce the fact that the Docker image you are deploying is signed. It won't allow you to deploy an image you would have generated locally, for example. Now that we know that we can run sign images, is there any way we could improve the trust in the execution? Meaning, how can we ensure that when you deployed this Docker image, you did not tamper anything in it? You did not edit the code that was running, because we are not using like compiled languages. We are not using C or C++, where you will have a binary that is more hard to tamper. So how can we do that? And the answer comes from Intel for now, at least for us and for now. And it comes to the form of SGX. So that's Intel's confidential computing solution, software guard extension. This extension is like physically engraved in CPUs, newest generation of CPUs, and it allows to run software in enclaves, isolated from the root operating system. And as usual, you can just take the SGX SDK from Intel, build new components using C, C++, or whatever, or you can rely on Softlegals to adopt SGX on existing applications. And that's what we did in the lab. Basically, we went for a solution that is now named Gramine, that used to be named Graphene. This solution allows to run existing application in SGX by wrapping them. Basically, Gramine here will act as a proxy between the CPU and the application you want to run. Gramine works by computing checksums during compilation time. So it will take all the application, compute what are the files checksum, and store them in a file that is called a manifest. And this manifest will be used, it will be cryptographically signed using a private key with 4096 bits at least. And this manifest will be used when you will start the application to check whether you tampered or not the files of the application. All of this is performed in an enclave, meaning that you don't have access to the process RAM or CPU calls or whatever. Everything is abstracted from your current running operation system. That means that the hardware checks the software, and the hardware prevents you from tampering data process. And it also means that you don't need to rely on a contract to be sure that you will not do anything harmful to the components, because you just can't. So in our case, we are starting to work with SGX2, which is the latest version of SGX. We are using FLC, which is flight launch control, allowing us to start enclaves that have a bit more memory than what SGX1 was providing at the time. And we're using the on-tree driver on Ubuntu 22.04, meaning that's quite accessible as long as you have a server that has the proper CPU. Well, one of the proper CPUs, the process should run easily. So I provided a few examples of a manifest. So this is a manifest for the compliance engine. As you can see, I specified the fact that I'm running a Node.js application. I provided the entry point of the application. I specified that I will use some environment variables that you are allowed to pass them from the OS to the running application and this kind of stuff. And after graminification, or after running Gramine on this manifest, it will provide me a signed manifest containing all the checksum of all the files that I specified in the manifest, meaning that those files will be checked at startup. If anything is wrong, you won't be able to run the software. That's let's say technical topic. We are still working on it, and there's a lot of work to do because Gramine and SGX2 are quite recent in the ecosystem. We also are taking a look at on the AMD side, because if we are able to, we would not like to soft lock us with Intel. But yeah, progresses are made. We are quite happy to say that at some point, you'll just be able to run a compliance engine and say, okay, I'm compliant and I can issue credentials for anyone. As usual, contributions are welcome. If you know about SGX, if you are able to provide SGX servers also to allow us to test, they are more than welcome. And as a reminder, we are targeting the Loire release. Tagus will remain unchanged. So that's a quite short presentation because I don't want to go too deep into details. It's like real hard even for me. As a reminder also, we are hosting TechX the 23 and 24th of May in Luxembourg. We do have a call for proposal that is open for a hackathon session and for presentation on the main stage. Every info are available on the website or on GitLab if you don't want to use the website. And I kindly ask you to send your proposal to me. And you have until the 18th of April to do so. And yeah, that's it. Thanks for your attention. I did not check the chat while talking. Is there any question, any remark? Do you want to discuss the subject, or did I lost everyone in a few seconds? Yeah, go ahead.
I have just a short question, whether the presented information, for example, the PowerPoint or especially the information about SGX is publicly available anywhere on GitLab or similar, or whether it's just in the presentation for now.
No, I do have a branch that is publicly available on GitLab that is named Built for Gramine, I think, on the compliance engine. So you can already take a look at it. You will see the manifest. I also have a small README if you want to test SGX. You can already take a look at it, and I will ask the comms team to add the current slides to the website where you had the event, so that you can retrieve the slides and have access to the code.
Someone sent a link for now. Thank you.
Yeah, perfect. Thank you. Vincent?
You're muted.
Sorry, I was just wondering, we did already discuss the subject before, but I never asked you about, you're talking about being locked in by Intel. AMD, do they have an equivalent enclave?
They do, but it's not exactly the same. On Intel SGX, your process and RAM are totally obfuscated from the operating system that is underneath. In AMD, I think that the RAM is shared. Well, you do have access to the running software RAM. I know that there is a small difference between the two. Hence, the reason we went for SGX for now. But okay, I know that ARM architectures, they do have enclaves because you have them on your phone if you have an Android phone or even an iPhone. So at some point, I hope that AMD will go to the proper way of isolating process and their RAM. So yeah, but for now, that will be SGX. Yeah.
Thank you.
You're welcome. Anything else?
Any question on the application for the clearinghouse? I don't know if we have clearinghouse operator or people interested by running a clearinghouse in the call today.
Nope. So
Looks like not. Okay.
too bad.
Any question, not necessarily maybe related to that topic? Any question for the CTO team or the staff in general?
Looks like everyone's head is already in vacation, and yeah, that's not a problem. As always, if you have questions afterwards, if you have ideas, feel free to send a message on Slack, on Teams, on Matrix, or even open an issue on GitLab. We are all monitoring all the channels, so yeah, feel free to ask us. And I think we will keep it short. We will go back to our sprints, and that's it. Thank you very much. Thank you, everyone.
Thank you, Evan.
Thank you.